Hi, welcome to this talk. Welcome to Devoxx. It's my first time at Devoxx and I'm enjoying it a lot. Hope you too. Let's start. I believe that every developer that cares about his product should have tests to the code. And when developing microservices, we have more challenges that we didn't have before. In this talk, I'll show you different approaches that I use when working with a testing microservices environment. So I work at Wix. Wix is a web-based platform that lets small, medium businesses to build a stunning website and manage their business in one place for free without any programming skills. And why I'm telling you about this? We have 130 million users, and we have over 800 microservices in production. So we are doing this a lot, testing microservices. My name is Maxim Novak. I worked at Wix for 4 years, and a lot of my time there, I'm building infrastructure services, which are services that take care of cross-cutting concerns like authentication, authorization, email, SMS, URL shortening, etc. And I want to show you a quote. The integration with your service was the easiest thing I've ever done. Said nobody. Never. And important part of my job is to make it easy for other teams to integrate with my services. So today, I'll share with you the approaches that we take to make it easier. So the agenda for today is to first understand what's the differences when testing microservices, why is it harder, and then we'll see different approaches to cope with this. So testing microservices. Is it more challenging? What are the differences? So let's start with a little bit of history. In the old world, we had our monolith. And we had the test. We can execute the whole code in one go, and we test our application. Or maybe we had a database. So we run an embedded version of this database, or run this database inside a container. But it's still fairly easy. But then microservices came. So we started splitting this monolith. So authentication is a different concern. Emails is different, maybe billing, and much more. If that's not enough, each and every one of them have its own dependencies. So it looks like this. And what I want to tell you today that it starts something nice and simple like this, but when your company grows, you have many users, the product grow, it ends up like this. Okay? Very quickly. So let's see how we can handle this mess. So the testing microservices is much harder because of the separation. So the code is spread in different places. Different teams write the code, and we can't run the whole system on our laptop. But we still want a short and reliable feedback loop, and we want to make sure that our test our assumption versus the reality, in terms of the logic of the service that we're talking to and the communication protocol. So before we dive in, let's recap on some test types that we'll talk today. And to make it easier for you to follow, I have this imaginary scenario, where we are developing the store application. We have a user that comes to our store, adds an item to the cart, make a purchase, and then the user should see a confirmation page. But the problem with it is that the store application doesn't know the name of the user, and we need to have the name in the confirmation page. So we have our user server that we depend on it, and it knows the name of the user. So one type of test that we want to do is end-to-end test. It's also called out-of-process component test. In this type of test, we will run our store application the same way as we run it in production, and then the test will interact with it. The problem that we don't have the user server because it's developed somewhere else, and later I'll show you how we solve this. So the orange line is the test boundaries. Okay, we run our application and then communicate with it in the same protocols as the user would. The second type of test that we'll discuss today is integration test. So obviously, inside our store application, we have some piece of code. Let's call it user's client that does all the communication with the user server. And we want to test that it works well. Here in the integration test, we also have the opportunity to test some edge cases or bad scenarios, etc. Unit tests are out of the scope here because unit tests should test the pure logic of your service inside your service. So let's see how we can approach this. So the first approach is don't test. But you probably don't want to go there. I mean, if you care about your application. Tests are very important to get a quick feedback loop, because you don't want to deploy your application to production to see that it's not working. So I want to talk a bit more about this. Some developers find a way around this. So they think that they're test, but not really. What they do is they have the user's client and also something else called stub user's client. And then in test, they have something like this. So if it's in test mode, use the stub user's client. If it's production mode, use the real one. And it can be this if statement, it can be some fancy dependency injection, but still, the important thing is that the application is aware whether it runs in test or in production, and we don't want this. And the reason that we don't want this is this. The real implementation is never tested. So we can't know that it will work in production. So you do want an out-of-process component test, which I'll refer as end-to-end in this case. By the way, the method here, it's a valid way to do other tests, like acceptance tests, but it can't replace the end-to-end tests that give us the confidence that our application works. And if you don't have these tests, I'm sure that you will have this embarrassing moment when you have some really tiny, small change in your application, you deploy it, and it breaks. And then you have this commit. Deploy it again, and guess what? It's not working. So now this one. And after a few commits like this, you give up and ask someone else to help you. So we don't want to go there. Okay? So this doesn't solve the problem for us. So let's see how we can test it. So the first try will be to run against external environment. So you could run your application against production or staging or some other environment. Let's see how it works. So we have our test, we have our application, and the user server is somewhere. So the good thing about it that we do check that it behaves like we assume, and we ensure that the communication protocol, the schema, is correct. Still, you can't test some non-happy paths. For example, the server is down, or the server returns some errors. And the bigger problem with this approach is that running against external environment is unreliable. It has high maintenance cost and adds complexity to your application. I'll explain what I mean with it. So first of all, our tests now need to do an external network calls, which can make them flaky. But other than that, it adds a lot of complexity. Sometimes the services that we use are doing some side effects on the world. For example, payment, SMS, etc. And you don't want this to happen. So now what? You will pass a parameter to the production. Is test equal true? You don't want to do that. Also, security considerations. Sometimes your server talks to another service with some secret key. So now this key needs to be in your test environment, which is, of course, less secure than the production. Another security issue is throttling. Sometimes the service that you're talking to will throttle you and will require CAPTCHA, for example. Your test won't be able to fill this CAPTCHA. Also, this environment is shared between tests, it's shared between teams, and from experience, it doesn't work in the long term. If something in the setup or tear down doesn't work, your environment gets corrupted, and you need to log in and start fixing things. So you probably don't want to do this. I mean, sometimes in the beginning, it looks very tempting, and some people do it. But when you're working like this for a while, you understand that you want a better solution. So please try to avoid this. The next thing is something called test doubles. This one we use quite a lot. And here, our service will talk to a stub or mock or fake. Over the same protocols, it talks to the real service. So if you are not sure what the difference is, there's a really good blog post by Martin Fowler that explains the differences. Basically, stubs provide canned answers that you pre-program. Mocks you program with expectations and the replies to these expectations. And fakes have some working implementation that usually have some shortcuts to it. So let's see how it looks like. So we have our application, and it talks to the fake server over HTTP. By the way, it can be any protocol. The HTTP is just for the example, and I guess that's what most of the people here do. So here we are having a fake that represents the fake server. So how this fake server looks like? So let's say this is the real server. In our case, the user server. It has an API, logic, validation, DAO, whatever. So in the fake server, we must have the API layer, the same API layer. But instead of the implementation, we'll have stubs or mocks or fakes. Okay, let's look at some code. We'll have a Java example here. So here's a purchase flow end-to-end test. This is from the perspective of the consumer of the API, the store, of course. So we generate a random user ID, random name, and we set up the fake. We tell it, OK, you should know that when they ask you with this user ID, you should return this name. Then you're doing your flow. You log in, you add item to a cart, and you make a purchase. As a result of the purchase, you get a confirmation page. And now you can assert that the confirmation page contains the name. OK, so this is the end-to-end test. We run, just to make it clear, we run the store application exactly the same way we would run it in production. And also, we run a fake user server, and we just test it. So that's the whole code. Let's move to, let's see how the integration test will look like. So in the integration test, we want to test only the piece of code that integrates with the user server. So again, we set up in a very similar way. We set up our fake. And then we are calling user server client.getName with the user ID, getting a result. And we ascertain this result. So we know that our user client implemented correctly. Now, we also have an opportunity to test some edge cases, for example, user not found. So in this case, we will set up the fake in a way that it will return user not found. Then we ask for the name, and we expect to get a user not found exception thrown from our client. Now, it's important to note here that because we implemented the stub, we can't be sure that it behaves exactly like the production service behaves. So for example, we assume that it will return us HTTP 404, but maybe it returns us HTTP 200 with a payload that says that the user is not found. So that's the disadvantage of this approach. So let's see what we got here. We do have a short and reliable feedback loop, but we implemented the test double in the way that we assume that it works, and not the way it works in reality. So we can't be sure that it will work. We test in the end-to-end our flow. It looks that the end-to-end test our flow. That's OK. But we can't be sure that the integration with the external provider is good. Another problem with this approach is when the provider has some internal logic that we rely on. Let's see a code example to show this. So this is a production code of the store application. Okay, this is the method that does the purchase. Of course, it's very simplified, but just to make this point here. So this method gets the user ID and the list of items. It calculates the price, sets a variable for is built successfully, then builds the user. If it's successful, set it to true. If it's a stolen credit card, set it to false. And then we render a confirmation page. We pass it this build successfully a parameter. So if we build the user, we said, hey, you got your items. And if it's false, we say the user, we couldn't bill you. Your order failed. Now we have this code, and your boss comes to you and say, you know what? We are seeing a lot of usage of stolen credit cards. Let's just block these users. Like, if a user comes with a stolen credit card, you want to block it. So you say, of course, it's really easy. I'll just add this line here. Okay? I know how to do it. I read the documentation. So we block the user. Now you're on your test. All the tests passed, of course. All the tests are green, and you ship it. But what you don't know is how render confirmation page works. And the way it works, it tries to get the name of the client in the beginning. But in case of blocked user, it will not work. So it will explode in production. And that's just because you didn't know how the user server works. There is another disadvantage with this approach. That if there is a service provider that have a lot of consumers, so most of the services in this company will probably use the user server, each team of the consumers will have to implement these test doubles. So it's a lot of duplicate work. So let's sum it up, this method. For the end-to-end, it solves our problem. But for the integration, it's partial, because we implement the test doubles, and it will work the way we assume, and not the way it works in the real world. And you can't trust them. So we worked with this method for a while, and a lot of developers from other teams used to come to me and say, look, this works in my test, but doesn't work in production. Help me with this. Why are my tests passing and production breaks? Consumer had troubles to integrate because they didn't understand stuff. And again, they implemented some fake doubles. It worked in their tests. You know, there is like this developer famous saying, it works on my machine, right? But we want it to work in production. So we thought that we need to find something better. We wanted a higher level of confidence. So let's see how we do it. Because we know that integration between teams is a very costly process, and we want to improve it. So the idea here is to move the responsibility to the service provider. So far, we saw a method that the service consumer can do himself. In this method, it's important to say that we need a cooperation between the teams of the provider and the consumer. So let's see how it works. The service provider provides something called a test kit, which is a lightweight version of the real thing. And then the user consumer can use it. It looks like this. So how the end-to-end test will look like? This test kit gives you also an opportunity to communicate better how your service works. So you can provide builders to set up the expectations. So in this example, we have a user test builder, and you can set to the user with ID and with a name and with any other field that you want. It might have like 50 fields here. But if you don't set any field, it will just be a default. And if we add the field, it will be added automatically in this approach, but in the test doubles, it will just not be there. So we set up the test kit, and then the same way, we just we execute our code, and we assert that the name is in the confirmation page. Okay, let's now look at the IT sample and the integration test. Very similarly, the setup is very similar. Then we execute the code, and we assert that the name is what we expect. The non-happy path. Now, we don't even need to set it up to say given user not found, because the test kit know how to behave when a request with a user that's not set up, it knows that if there is no such user set up, it needs to return user not found. So it's even easier. And then we test that we expect the user not found exception. Let's see the special case that we saw before about the blocked user. So now in the IT, we can also set that the user is not active. And then we invoke the code, we set it up, we invoke the code, and we see user not found. We also know that we have a back office API that will show us blocked users. So in this case, we can test it as well. And now we can make sure that the regular API will return user not found for blocked users, and the back office API will return the user. So no guessing anymore. You can just test it and be sure that it works the way you think it works. So what does the consumer get? So you get a class. If it's Java, we usually have a start and stop method. If it's HTTP or some web, it have a port usually. And we have some methods that will help us to set it up. So we can say given user, and we can update user, and etc. Now for the update user, we don't provide it a user because some fields can be updated, some fields can't. So again, it's your way to communicate with your consumers about your contract. So you're convinced. Now you want to build a test kit. Let's see what needs for this. So as a test kit developer, you need to understand what is a test kit. So in this bar, we have test doubles on one side and the real thing in the other side. And test kit is something in between. And for every use case, it can be something else. It really depends on you, on your needs, and you decide what goes in and what not. So let's start looking at how it looks like. So if this is the real service that you provide, of course, we will have the API layer. And now we start picking up which things we do want from the real code. So for example, we decided we want to do validation, the same validations. For example, the user is UUID, and if we get in string, we want to throw an exception. So we put it here, the same implementation from the real code. Sometimes you want to take some logic. So we have two parts of logic here. We'll take logic 1. And usually when you have logic involved, you sometimes also want a database. So if you have a database, you just replace it with an in-memory implementation of the database. Also often, you want to play with the time. For example, you have a coupon service, and you know that the coupon expires after 1 week. So you don't want your test to run for a week, right? You want to be able to say, now go a week forward. So you change and you put some time mechanism that you can control from the outside. And an important thing here, so we decided that we are taking most of the stuff, we are not taking logic 2. Now, what about the database? We don't want that each test, as I said before, it's a lightweight version of your thing. So you don't want to bring other dependencies. Of course, you don't want to run another database for your consumers, because if your consumers use 20 microservices, and each one of them will have a database, so it's a lot of databases, a lot of memory consumption, a lot of resources. So we will not bring our next dependencies, not services, not databases. So how do we solve this? With the integration contract test. Also, if you want to read more about this, there's an excellent blog about this by Martin Fowler again. But I'll explain briefly. So it's the same test that runs against two implementations. Okay, so me, as a service provider, I replaced my MySQL DAO with an in-memory DAO. And the same test that I run against my MySQL DAO, I will run against the in-memory DAO. This way, I'm sure that it behaves the same. And we are applying the same technique for the whole service. So these tests are more to make it easier for me to develop, but we also apply this in the server scope. So we are writing integration contract test that run the same test run against the real user server and the user test kit. Okay, I'm as a service provider, I'm responsible to do it. And because I'm doing so, my consumer, the store here, they know that when they run their test against the user test kit, it will behave exactly the same like it will behave in production with the real user server. Now, we have all these benefits about tests, but when we are writing test kit, we have another benefit, which enables you to communicate better with your consumers. Okay, this is not related to tests, but if you're doing test kits, you also get it for free. So now your consumers run your code. So it's a live contract between them and you. And if you change something, let's say you change the validation, and they use it in a way that it will not pass your new validation, a test will break, and then you can decide what you need to do. Maybe they have a bug, or maybe you did a breaking change. And you can see this, and you can decide it before you discover this bug in production. Also, so it's like much better than documentation, because documentation gets stale, and even if it's not gets stale, like nobody reads this. So this live contract that runs in the continuous integration. Now, another benefit here, that you can put your new test kit logic here. So this way, another way to communicate with your consumers. So for example, you want to deprecate a method. So now you can write log when every time they call this method, you can write log that they will see, hey, this method is deprecated, please stop using this. Or you can throw an exception, and then their test will break, while in production it still works. Okay, so it's a very nice way to communicate, and it works good in large-scale organization. Now, of course, it has also disadvantages. So one big disadvantage of this method that it's a lot of development. So the teams that are responsible for it have a lot of work to do. And also, it brings a lot more build dependencies. So now, all the consumers depends on the implementation of your service in CI/CD. But we do get an end-to-end solved and integration solved in the way we wanted. We are getting the short feedback loop, and we are getting high confidence that it really works. That if it works in test, it works in production. That's the goal that we want to achieve. That if something fails, we want it to fail in tests and not in production. It's much cheaper to fix it, and no user impact. So we saw a few approaches here. Let's wrap it up. So the first one was not to test it. Probably you don't want to go there. Then we saw that you can test against external environments. Well, it might be tempting in the beginning, but try not to go there as well. Then we saw the test doubles approach, which is a legit way, in my opinion. We use it a lot at Wix, and it's easy. It's just easy to do it. It's very quickly, very easily. And then the last way, which is test kits, which give you the highest level of confidence, but have a lot of work. And then you have the dependencies issue. So there is no rule like when to use what. A general rule of thumb is that I usually look at the number of consumers and the complexity of the API. So if the API is simple and you don't have many consumers, just go with the test doubles approach. You don't have a lot of integration problems, and it's pretty easy. If your API is very complex, or you have a lot of consumers, you have a lot of integration issues, you need to help a lot of consumers to integrate with you, go with the test kits. We finished a bit before time, so if you like this talk, please rate it, and I'll take questions if you have. Any questions? Okay, so I'll hang out around here. So if you have more questions or want to discuss it with me, feel free to come by. Thank you.